if the probability is 0.54, that stock A will increase in value during the next month, and the probability is 0.68, that stock B will increase in value during the next month, what is the greatest possible value for the probability that neither of these two events will occur? So this question is a very hard question, I think, and I actually think it is a bit of an unfair question because for almost every probability question that the Gmat can ask you, and in fact, I think this is the only one where this is not the case. They will give you a scenario where you have independent events. So they will be talking about something like coin flips. And so when you are flipping a coin 3 times, by independent, I mean the outcome of your first flip has no impact on the outcome of your second flip. You are always going to have a 50% probability for any individual coin flip of getting heads and a 50% chance of getting tails. So even if you have 10 heads in a row, the probability of getting a heads on your 11th flip is still going to be 50%. And so because of that, if they were to ask you, and a lot of times they'll even specify that you have independent events. They'll say something like, if a fair coin or if a regular coin is flipped 3 times, what they're telling you is that the probability is the same and it's equal for both outcomes. So when you have independent events, if they were to ask you something like, so what is the probability of getting heads on all 3 coin flips, that should just be 1/2 times 1/2 times 1/2, which is 1/8. Now, say you have a scenario such as something like stocks. Let's say, so we got it. Let's say we have a situation similar to our coin flips where we got 3 stocks. And this is really why when I say this question is a bit unfair, why do I say that? Because so when you have a situation like stocks, those events, especially the movement of stocks, well, those events are not necessarily independent of each other. And so when I say this is a bit of an unfair question, I wish they had at least just specified somewhere that, this stock, they give you the probabilities and then say if these events are not necessarily independent of each other, blah, 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 blah. One thing they do say greatest possible value. So that's one sort of hint that if you're trying to solve for just a single probability, you might not be able to. So let's say we have a situation with our stocks that is similar to our coin flips where I have 3 stocks, 1, 2, and 3, and each stock has a probability of 50% of going up. And then I was to ask, what is the probability that all 3 of my stocks go up? Well, in this case, we cannot just say, okay, that will be 1/2 times 1/2 times 1/2, because it is possible that our stocks are correlated with each other. So especially like in a scenario where, say, stock 1 is a company that makes computers and stock 2 is a company that makes the chips for those computers. So in that case, once we know that stock 1 has gone up, well, that is going to affect the probability that stock 2 will also go up. So the probabilities are sort of conditional based on whatever events occurred before it. And so here we cannot just find a single probability. We have to know something about how our stocks are correlated with each other. So in our scenario, what do we know? So we got stock A, and we got stock B. And so we want stock A has a 0.54 chance of going up overall. Stock B has a 0.68 chance of going up overall. And then we want the probability that neither of those things will occur. So the probability that stock A will not go up is 0.46. And instead of saying the probability that it won't go up, the double negative is confusing. So I'm just going to say event A and event B, where event A is the probability that A doesn't go up. Event B is the probability B does not go up. And so for stack B, if it has a 0.68 chance of going up, it should have a 0.32 chance of not going up. And so now we're saying we want both of these things to occur. And so let's think about this. So overall, stack A has to have a 46% chance, or the event A has a 46% chance of occurring, and event B will have a 32% chance of occurring. But if we want to maximize the probability that each of our events will occur, we should make our two events maximally correlated with each other, meaning once we know stack A goes up, we know stack B has to go up, and the same thing is true with stack B. If once we know stack B goes up, we know stack A has to go up. So in other words, we have sort of two scenarios we can think about here. And so if they are maximally correlated with each other, we are maximizing the chance that both events will occur. But we have two scenarios, because either first event A occurs and then event B occurs, or first event B occurs and then event A occurs. And so in this case, so we are saying here, B is 100% correlated with A. So first we have to have event A occur. And so what is that probability? That will be 46% chance that that will occur. And then once event A occurs, we know event B must also occur. So this will be a probability of 1. And so in this scenario, we were saying A is maximally correlated with B. And so we're saying once we know B occurs, we automatically know A occurs, but we still need to know what is the probability that B will occur. So that will be 0.32. And then once that occurs, we got a 100% probability A will occur. So let's think about what are these numbers here telling us. So before we just say, oh, 0.46 is greater than 0.32, the answer is D. Let's actually think about what is going on here. So each of our scenarios, it's really telling us something about our second event. So in this first case, it's telling us something about event B, and in our second case, it's telling us something about event A. So in our first case, this is saying that at a minimum, event B must occur 46% of the time. And the reason for that is because, so even if event B never happens, except when event A happens. So that's the only time event B happens. Well, event A is still only going to happen 46% of the time. And so remember, we maximized our correlations here. So that means B will always have to happen at least 46% of the time. And in this case, what are we saying? We're saying at a minimum, A will occur 32% of the time, because even if the only time event A occurs is when event B occurs first, well, event B will still occur 32% of the time, and so that means event A will also have to occur 32% of the time. Now, are each of these two things possible? We know that we are always limited by our overall probabilities, right? So we cannot say that at a minimum, event B will have a 46% chance of occurring, because we know overall it has a 32% chance of occurring. So this is actually not possible, but this guy is possible, because we know stack A has a 46% chance overall, or event A has a 46% chance overall of occurring. And so to say at a minimum it has a 32% chance of occurring, that's fine, because we got some more wiggle room here. And so in other words, this was all a 10-minute explanation of really just saying, whenever you have events that are not necessarily independent of each other, if you want to know the probability of both of them occurring, you're always going to be limited by the smaller individual probability. So in this case, the 0.32, and that is our answer, B.